Good morning and welcome to Science on Tuesday. Today you will need your journal out and you're going to need your science book. We're going to be on page 30 in your science book, and we'll start with some notes. Working on scientific research. Remember, at any time during the video, if you're behind, you can politely ask for Miss Landrum to pause and you can finish writing or catching up. You're welcome to write in your science books. Please make sure you're using your book. It should have your name on the front cover. If you don't have enough room in your journal, there is notebook paper at the front of the room on the little bitty white shelf by the yellow pole. And let us begin. The first word we're going to look at is research. Scientists define a problem, and after they have their problem, they begin their investigation with research. Research just means they study a variety of different, let's see what they said. Study a variety of reference materials about a subject. A variety of different materials about a subject. Their research, they look things up. They don't just sit there and do their labs. They read about what they're looking at. They analyze, they look up videos, they ask friends. Research can also be looking into your mind and thinking about your prior knowledge, your schema. What do you already know about a topic? You're welcome to draw that in the book, circle that, underline that. You can read some of this if you need to. The next word we're going to look at is hypothesis. Scientists use a problem they have defined and research from appropriate sources to form a hypothesis. A hypothesis is a very good guess of what you think will happen. Let's see what the book says. A statement about what you think will happen during an investigation. So what you think will happen. This is your hypothesis. It's a good guess, not just a random guess. A very good guess. It's normally written in an if, then, because statement. So it's written as, if something happens, then this should happen because da 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 da. So it's not just what you think, you've got to explain it. I'm thinking this is going to happen, and you got to have this because part. This might be the most important part right there. You can write a good guess, but you have to support it with a reason. Why do you think this is going to happen? That's the hypothesis. Oh, I like that underline. That was nice. Maybe we should go back and underline these. Yeah, that makes them look nicer. You know I messed up my pages, didn't I? I said we're on page 30, but that wasn't page 30. You can tell by right over here. That was page 11. I'll try to do a better job tomorrow. Observations. We just talked about this when we were Skyping with the Grand Canyon a few weeks ago. Observations. Things you can see with your eyes, or you can use your other senses. Remember, this is a lot of the classes we were having trouble. We kept wanting to make inferences, but observations are just things you can see, like size, color, texture, shape. Observations are easier than you think. It's just the obvious. The chair is green. The chair is short. The chair has metal legs. Those are things we can see. You don't have to think about them. So those are your observations. The other word we learned last week was inferencing, or a few weeks ago. Inferences. It comes up later in the book. Inferences are not things you can't see. These are things you have to figure out. So you look at something, that's your observation, and you use what you're looking at and then you have to use your head and really think, what does it mean? Because I see these colors and textures and shape, now I can infer, I can draw a conclusion, I can figure out that this has to happen. And that's how we did the fossils. We looked at the size, the color, the texture, the shape of the imprints that we saw, and then we inferred that there must have been an ocean there. So we looked at, you don't have to write maybe this part down unless you really want to, and shape to figure out that a fossil was there from an ocean. We inferred that an ocean used to be here. That's what we figured out based on all that stuff. That's the inference. The inferences are a little bit harder. Please push pause if you need more time there. No, that's not what I wanted. That's what I wanted. We're going to skip that page and that page. An experiment. Well, we're not going to do an experiment, but here's what an experiment is. An experiment is the use of scientific investigation and reasoning to test your hypothesis. Let's see if they have an easier one right here. The use of scientific investigation and reasoning to test a hypothesis. Because your hypothesis was your very good guess about what you think is going to happen. So now you have to test it with an experiment. You have to design a lab, an investigation, to test and see, is your hypothesis correct? Models. We've talked about models before. Models are objects or ideas that represent other things. Most of the time our models are limited. They're not always the perfect example. Like we had to use the hot plate for the sun. A hot plate doesn't really model the sun very good when you think about color, size, shape, but it does do the job of giving us thermal energy, just like the sun. We used model volcanoes several weeks ago. They're nowhere near like the real ones, but they help us to understand and to observe and see an eruption under a safe condition. Page number 22. So this is the scientific process. You start by asking a question, a well-defined question about something you observed, like, what will keep the apple slices from turning brown? That's a question. Now they're ready to make their hypothesis. Is a possible answer to the question you ask. It has to be able to be tested. So, will lemon juice keep an apple from turning brown? That's the question. If I put lemon juice on the apple slice, then it will not turn brown because the juice keeps the apple from reacting with the air. This is the, you got it? Hypothesis. That's right. Thank you. That's the hypothesis. Notice it has the because in it. If we do this, then this will happen because. That's the hypothesis. Now we're ready to be able to test it. From a hypothesis, a scientist can identify the variables. A variable is something that can change in a test. So variable, something that can change. Look at that base word, variable. If you take off the able, the base word is vary, V-A-R-Y, and that means to change. Sometimes the weather varies outside. It changes all the time. They have independent variables, dependent variables. These are two different things. Both variables are usually present in an investigation. The independent, you think I could do this, variable is the one that you can control. The dependent variable changes when the independent variable changes. This is the one that you don't control. Oh, that's too much. Really liking that underline right there. Let's see if they have it over here. The independent variable. No, they didn't put that on here, did they? And the dependent. A simple investigation should test only one variable at a time. And that's what we have in 5th grade. We only test one variable at a time. Too bad this isn't matching up, but you're welcome to highlight that in your book. And I don't mean with a real highlighter, I just mean with your pencil. You can circle it, you can underline it. We should test only one variable at a time. And we've been practicing those questions on our Daily 10. Another word is control group. I don't think I like that definition. A standard against which change is measured. It's a group that you don't change at all. So on the apple example, the control group, if we were putting lemon juice on some apples, we would then want one apple to not have any lemon juice. That would be our control group. We know what's going to happen to that apple without lemon juice. Maybe this apple will put a little lemon juice, this apple a medium amount of lemon juice, and this apple can just swim in the lemon juice. That would be our independent variable. That's the one we're controlling. We are controlling how much lemon juice got on the apples. 0, a little, a medium, a lot. The dependent variable, it is dependent. We don't know which one's going to do the best. We have a good idea the apple without lemon juice is not going to do well. It will turn brown. But the other three, is a little bit of lemon juice enough? Or do you need a good amount of lemon juice? Or do you need tons of lemon juice? So those are the difference between the independent. They are independent, like you're independent when you do an independent assignment. You're all alone. You're by yourself. No one has to help you. The dependent variable means it depends on something else. You can't be by yourself. So whether or not they turn brown depends on the amount of lemon juice, but we put the amount of lemon juice on them. The control group was that one apple we are controlling, and it doesn't get lemon juice. It's not the best definition, but it works. One part of your experiment that you leave alone. The control group. We're not doing anything to that group, so we can see what normally happens to that group. Let me turn back to my hand. Then we make the plan, we test the hypothesis, we collect, record, and interpret the investigations. Then we communicate our conclusion. Oh, but here's an important part right here. We do repeated trials. Too bad there's not like a pencil. I can just circle this myself. Just put a big box on it. We do repeated trials. We repeat the investigation. And we've talked about this before too. We do the experiment more than once. We don't just do it once because something might have gone wrong. So mostly in our class we try to do it 3 times. Repeating the trial, doing the experiment over and over and over. This gives us better results.